All right, everybody, we are approaching the end of Chapter 4, and unfortunately we end on a kind of tricky subject. We're going to do a couple of integrals that need a special technique in order to solve, and this technique is called integration by parts. And I'm going to be honest with you, I didn't learn this technique until Calculus 2. And so I'm not 100% sure why it's in our curriculum, but that's okay. I'm going to show you how to do it, and I think after a couple practice problems, you will be able to do it yourself. So integration by parts is when we are taking an integral and it works for some things, it doesn't work for others. The problems in this section it will work for. It's when you have two different types of things being multiplied together, I would say, is when it works the best. Kind of what integration by parts is a double U substitution. That's sort of kind of what it is. I'm not going to prove it for you, but the idea is the formula is uv minus v du. In fact, let me give you the complete formula really quickly. And again, it's sort of kind of like a double U substitution. All right, so here's what it is. It's the integral of u dv equals uv minus the integral of v du. And when I learned this, my TA gave us a clever mnemonic device. It's ultraviolet minus video. uv is ultraviolet minus the integral of video, v du. Anyway, that's why I could remember this half of it, but not this half. So the integral of u dv equals uv minus the integral of v du. Anyway, I'm just going to kind of show you how to do this. We need to pick a u, we need to pick a dv, and then we get v and du from it, and then we can just plug it into this formula. And in a full calculus class, I would show you where this formula actually comes from, but for now, don't worry about it. Now, you want to pick u to equal something that'll become more simple when you take the derivative of it. So we're just going to go through these examples. In this problem, you would want to set u equal to 9x, which means that du is equal to 9 dx. So that's good. So that's our u. So if our u was 9x, then that means our dv will be, oh, that's how I could have remembered it. Our dv will be e to the 5x. Okay? So notice here we took a derivative. Here we need to take an integral. So we took the derivative of u to get du. Now we need to take the integral of dv, and the integral of e to the 5x is going to be e to the 5x divided by 5. And don't worry about the plus c for now. So that's going to be e to the 5x over 5. Notice if I took the derivative of this, the chain rule would make a 5 come out, which would cancel, and I'd get e to the 5x. So here are the four pieces of what we want, and now we just plug them into this formula up here. So it's uv, so 9x, uv, so 9x times e to the 5x over 5. And luckily, all of that is out of the integral now. Notice that this is not in the integral anymore. And hopefully these other two pieces are simpler than the original integral. So we did uv, u times v, and now it's minus v, which was e to the 5x over 5, times du. And du was just 9. So now it's just 9 dx. So that's uv minus the integral of v du, which is 9 dx. Okay, so take a look at that and see how I substituted that all in. So this is just 9x e to the 5x all over 5 minus the 9/5 I can pull out of this integral. And you can see that that's a much easier integral to do. And so let's do it. Again, this first term will stay the same. That's just the first term, and then the integral of e to the 5x we already did is e to the 5x over 5. So this will be minus 9 over 5 times e to the 5x over 5, like that. And let's just simplify that a tiny bit. That'll be 9x e to the 5x over 5 minus 9e to the 5x over 25, just like that, plus c, because we just did it. Now you put in your plus c because we just did an integral. So I know that's a little bit tricky. You will be able to get it if you just follow the steps that I just showed you. You want to pick something simpler for your 9x that simplifies, because that way your inside integral becomes a lot simpler when we do it. All right, so hopefully that makes sense. If not, please send me an email. You could have simplified this a bit more by factoring out 9e to the 5x and a 5, I suppose, but I'm just going to leave my answer like that. Let's do another example before we wrap up. Once again, the formula is u dv equals uv minus v do. Okay, so this one's a little tricky. Last time we picked the 9x to be our u. This time, if you pick 10x to be the u, you're going to end up spinning in circles. And so with experience, you'll pick 10x, you'll figure out that it doesn't work, and it's like, okay, let's try to let something else equal u. So this time, we actually want to let u equal the natural log of 3x. And again, I've done very many of these, and so I kind of have an instinct for what to let u equal. You will get that instinct too if you do enough of these. Or if you just figure out that if you let u equal 10x, it just does not work out. And it doesn't work out because the integral over here, when we get to doing the integration by parts, is no simpler or even worse than the integral that we started with. All right, enough talking. U equals natural log of 3x. Du will then equal 1 over 3x, right? Because we take the derivative of the natural log, times 3, because of the chain rule. So the derivative of the natural log of 3x is 1 over 3x times 3, because of the chain rule, which is just 1 over x. Okay? All right. So now we're going to do dv, which will be 10x. And remember that we're doing an integral of dv to get v. So that's going to be 10x squared over 2 is going to be the integral. Don't worry about the plus c. Notice the derivative of this is this. And so that simplifies to 5x squared. And that's good. We're now ready to plug in. So here we go. We focus on this piece over here. So it's u times v, so the natural log of 3x times 5x squared, which I'll put out in front. So that's u times v minus the integral of v du. So that's 5x squared times du, which is just going to be 1 over x. I should have put a dx here, sorry. Okay, so that's uv minus v du, and then the dx at the end. Notice that this is a much simpler integral. In fact, the 1x and the x squared even cancel. So we get 5x squared ln of 3x minus the integral of 5x dx. Happy days. That's going to be 5x squared ln of 3x minus 5x squared over 2 plus c, and we're done. Okay, and so that's the answer. And if you have a question about how that is, please email me because I'm happy to answer your questions. Just follow this formula as a guide. You pick u and dv, derivative to get du, integral to get v, then just plug it in over here, and hopefully you'll get a simpler integral that you're able to just take regularly. By the way, it is possible that you sometimes have to do integration by parts more than once, and so I think we'll see an example of that in the next video. If you have any questions, please email me. I will see you in what will be the last video for Chapter 4.